Hi everyone, welcome. Here are the big takeaways from the Chapter 8 topic of controlling extraneous variables and the Chapter 11 section on confounding and obscuring variables. Now the first big takeaway from this lesson about control processes in research design that remove from an experiment the influence of extraneous variables. Now to the extent that the influence of extraneous variables can be removed from any experiment, the true cause and effect relationship between the independent variable and the dependent variable can be perceived. Remember that? This is the logic of experimental design from an earlier chapter. So how exactly do we remove the influence of extraneous variables? That's our topic today. Through what we call control processes, and there's 3 techniques in particular that you need to know. Let me say that the first is random assignment to groups. That is, randomly assigning participants in your sample to the comparative groups of your independent variable. Now I'm talking about before the experiment begins, where you've gathered a sample of participants and then you're deciding which participants will be assigned to group 1 versus group 2, or be assigned to your experimental group or your control group. Random assignment means exactly what it sounds like. We randomly select people out of your sample one at a time, and one person goes to group 1 and one person goes to group 2. The next person goes to group 1, the next person goes to group 2. As a result, we are not likely to see a clustering of any specific characteristics in group 1 or group 2 of your independent variable. Imagine gender, sex of the participant, is an identified extraneous variable in your study, and you want to control for its influence on the outcome of your experiment. We would want to avoid gender clustering, that is, cluster a large majority of women, for example, in group 1 versus the other. But maybe that would be largely men. By random assignment alone, you're not likely to see these kind of clusters. So that's our first technique. Remember, the logic of experimental design says that if 2 comparative groups are otherwise equal to each other in characteristics, in this case equal in gender distribution of males and females, then any differences observed in the outcome scores for the dependent variable must be due to one thing and only one thing. That's the independent variable, not some extraneous variable like gender in this example. Now, after random assignment to comparative groups, the most common ways to control extraneous variables are, number 1, to balance or equalize characteristics explicitly across your comparative groups, or number 2, remove extreme characteristics of certain participants. That means removing some people. So let's look at the first one. To balance or equalize characteristics would mean that I go out of my way to carefully balance my comparative groups on a particular extraneous variable, such as ethnicity or race in a different study. I may choose to balance the comparative groups of my independent variable to ensure that race is equally represented in each of my comparative groups of my independent variable. Here, I fulfill the logic of experimental design by making the 2 comparative groups of my independent variable as equal to each other as possible, removing the likelihood that race or ethnicity has any influence on differences observed in outcomes for my dependent variable. Now, the last technique for controlling extraneous variables is to remove extreme characteristics. These are the outliers of an identified extraneous variable, which, if included in our study, if we included these people, could really throw off our research results. For example, in a study of the effectiveness of an after-school tutoring program in elementary school kids, I probably want to remove the extreme characteristic of being a straight A student or being an F student. That is, I recognize my sample has A students, B students, C's all the way down to F students, right? But I know that A students have too little room to show improvement from my tutoring program. They're already A students. And F students may be struggling with issues that go beyond what a tutoring program can solve, and I may not see any results with them. So I may choose to remove A students and F students, these extremes, these outliers, from my study sample. As before, we would want to avoid clustering of either A students in one group or F students in one group or the other group, because to do so could influence differences observed in outcomes for my dependent variable. So these are the 3 primary ways we remove the influence of extraneous variables when designing an experiment. Takeaway number 2 here. Be sure to know a special kind of extraneous variable called a confound. This is an extraneous variable that the researcher has accidentally manipulated in the process of designing a research study. That is, the researcher has accidentally built into the experiment an extraneous variable without realizing it. For example, in a study of the effect of psychotherapy, real common study, the effect of psychotherapy, right? A researcher may hire two different therapists to carry out the experimental group versus the control group. If one of those therapists has 2 years of experience and the other therapist has 10 years of experience, an extraneous variable has just been introduced: the level of experience of the therapist. Outcomes in my experimental groups are likely to be influenced by the more skilled, experienced therapist in one group, and this offers an alternative explanation for any results observed. Even after careful consideration, a researcher can overlook an extraneous variable, and the confound is special because the experimenter has accidentally introduced it themselves. Finally, the third takeaway in this chapter is about cultural competence in research methods. Read about how easy it is for a researcher to have an ethnocentric view. Normal cognitive processing means that we tend to view other people and other cultures as an extension of our own, starting with the assumption that others share my viewpoint, my values, my skills, my abilities. That's normal. Having an ethnocentric view in our research idea and in how we implement our research study puts boundaries on our judgment, our interpretation. It's how we make mistakes. Read about two components of the research process where we often demonstrate our ethnocentric thinking, and that includes sampling, number one, and in our choice of instruments, or the technical name for that is apparatus, choice of apparatus, which must be an equally available form of communication for all the participants in your study. So in summary, the big takeaways from this Chapter 8 topic on controlling extraneous variables and Chapter 11 on confounding and obscuring variables are these. Number one, the most common ways to control extraneous variables are: number one, random assignment to comparative groups; number two, balance characteristics across groups; and number three, remove extreme characteristics of certain participants. Number two, I want you to read about the confound, a special category of extraneous variables you want to know about. And lastly, last takeaway, cultural competence in research design means becoming aware of the ways that participants in our sample may be different from the researchers themselves. Those are the big takeaways on this topic, guys. Thank you, everyone.